Assalamu alaikum. Hello everyone. Today I'm going to discuss with you some problems and theorems, basically theorems from the mechanics. First I will give you the um, definition of mechanics and some conceptual knowledge on mechanics. There are two parts of mechanics. One is statics and another is dynamics. What is mechanics? The mechanics is the branch of statics, branch of science that discusses the effects of forces on any objects is called mechanics. In mechanics, we actually study and discuss the effect of forces on any objects. Okay, and if the objects is not moving, then that branch is statics, and the object is, if it is a moving object, then it is then that branch will be called dynamics. Okay, now in statics, the branch of mechanics which discusses elaborately the state of immobility of a body under the action of forces and characteristics of the forces acting on the static body. In statics, when the object is not moving and a force is applied, and then the characteristics of force and what will happen of the on that object, this we try to find out mathematically in this branch. But in dynamics, the object is moving and force also, if apply force, then what will happen, that we will try to find mathematically through dynamics. Okay, now first of all I'm going to show you a theorem, proof of a theorem. Here, this theorem, I hope you can see magnitude and direction of the resultant of two forces P and Q acting simultaneously at a point inclined at an angle alpha to each other. Okay, here two forces P and Q acting at the point O in this figure, and in this figure two forces P and Q acting at the point at this point. Okay, now for figure 1, when alpha is an acute angle, here acute angle means it is less than 90 degree. Okay, so here for this figure, OD is equal to AD plus OA. We can write this OA plus AD, but AD by AC is equal to cos DAC, so that's why AD will be AC cos DAC. Similarly, the which implies OD is equal to P, we substitute OA by P and AC by Q, so P plus Q cos alpha. Similarly, CD by AC equal to sin DAC, so CD is equal to AC sin DAC sin alpha, so CD is equal to Q sin alpha. Okay, now come to the next in figure 2, when alpha is an obtuse angle, here OD is equal to OA minus AD, so OA we substitute AD by AC cos DAC, so P minus Q cos pi minus alpha, so P plus Q cos alpha. Similarly, CD by AC sin DAC, CD is equal to AC sin DAC, sin DAC we can substitute DAC by pi minus alpha, so CD is equal to AC sin alpha, so which implies CD is equal to Q sin alpha. Okay, now in the right angle triangle OCD, we get OC square equal to OD square plus CD square. We can substitute OD by P plus Q cos alpha whole square, and we can substitute CD by Q sin alpha, so we get P square R square equal to P square plus Q square. How we find Q square here? Because here it first we apply A plus B whole square formula, A square plus 2AB plus B square. Here Q square, if we take common Q square, we get Q cos square alpha sin square alpha, so R square is equal to P square plus Q square plus 2PQ cos alpha, and tan theta equal to CD by AD, CD by OD. Okay, so OD is equal to P plus Q cos alpha, so we get tan theta equal to Q sin alpha by P plus Q cos alpha. This is the formula we will need to solve many problems in this section. Now then I want to show you when we will get the maximum value of this resultant. R will be maximum if the alpha is 0. Okay, for in this formula, if alpha is 0, we get p square plus q square plus 2pq cos 0. Then we get p square plus 2pq plus q square, p plus q whole square, which is p plus q. When r becomes minimum, that means p square plus q square plus 2pq cos 180 degrees. If alpha is 180 degree, we get p square root over p square minus 2pq plus q square, p minus q whole square, that which implies p minus q. Okay, now so r becomes maximum, r will be maximum if when we get the sum of the two forces, and r will be minimum and if we do the subtract or difference between the two forces. Okay, now next, another important formula and theorem, also theorem as well as formula. Algebraic sum of the resolved parts of two forces acting at a point in a given direction is equal to the resolved part of their resultant in the same direction. First we have to draw this parallelogram OSCB in this figure and in this figure, and then we have to draw the perpendicular line BE AD CL, similarly AD CL and BE. Here between the two triangle OBE and AMC, BOE is equal to CAM and OEB and AMC equal, because they are right angle, and OB and AC are equal, so they are congruent, hence OE is equal to AM equal to DL. Now algebraic sum of the resolved parts of P and Q along OX is OD plus OE. OE is equal to DL, so OD plus DL is equal to OL, and its resolved parts of the resultant R along OX is OX OD minus OE, OD minus DL is equal to OL. Okay, that's we need to find. Now here in this problem, here this is a rectangular, we have to find the resolved part of the component of this forces R. Okay, what will be the component of R along this line OX and along this line OY? Here notice AOC is equal to alpha, so BOC will be alpha pi minus 2 minus alpha, so cos alpha is equal to OA by OC, so OA is equal to OC cos alpha, so this is R cos alpha. Similarly OB is equal to OC cos alpha by 2 minus alpha, so OB is equal to OC sin alpha, so OB equal to R sin alpha and OA is equal to R cos alpha. This is the formula. Now another formula we will need in this chapter here in OSCB. Okay, in OSCB parallelogram, in OSC, here if the AOC is alpha and BOC is beta, then OCA also beta, and CAX is alpha plus beta. So if we apply the sine formula in triangle OAC, OA by sine OCA, AC by sine AOC, and OC by sine OAC, so P by sine beta, Q by sine alpha, R by sine pi minus alpha plus beta, so P by sine beta, Q by sine alpha, R by sine alpha plus beta. This is the sine formula we will need in when we solve the problems. Okay, now let's see one or two problems from this chapter. First of all, this here, let's see here two forces of magnitude P plus Q and P minus Q act at a point and at an angle twice alpha. The resultant makes angle theta with the bisector of the angle between them. We have to show that P tan theta is equal to Q tan alpha. Okay, here I hope you can see this P plus Q acts along this axis. Okay, this is OX and suppose this is O, and P minus Q acts along OZ, and their bisector OX is OI is their bisector. Okay, so this bisector makes theta, angle theta, with their with the line of their resultant O, which acts along this line. Okay, now what will be the angle between P plus Q, and the angle between P plus Q and P minus Q is twice alpha, and P plus Q and R is alpha minus theta, and P minus Q and R is alpha plus theta. So by applying the sine rule of forces, we get P plus Q by sine alpha plus theta, P minus Q by sine alpha minus theta, and R by sine twice alpha. So taking first and second ratios, we get P by P plus Q divided by P minus Q is equal to sine alpha plus theta divided by sine alpha minus theta. If we apply componendo and dividendo, we get P by Q is equal to 2. Here sine A plus B plus sine A minus B will be 2 sine alpha cos theta, sine A plus B minus sine A minus B 2 cos alpha sine theta. So P by Q is equal to tan alpha cot theta. Then we get P tan theta is equal to Q tan alpha. This is the required proof we need to show in our problems. Another problem we have here, this: if the resultant of velocities A and B acting at a point C, and the orthogonal resolved part of C along A is B, then show that C is equal to root over B square minus A square plus 2AB. So here the first we see the two velocities A and B act at the point O, and the resolved part of the resultant C along the line of action of A is B. This language you should try from your own. This is the gist part. C cos theta is equal to B. This part you have to understand basically. Okay, this language and figure, try to draw it from your understanding. Okay, so C cos theta from the question actually. So C cos theta is equal to B. It is given in our problems. Okay, in our question. Now if we take the resolved part of the velocities along the line of action of A, we get A cos theta, A cos 0 plus B cos alpha and C cos theta. We know that the resolved part of the two forces, sum of the resolved part of the acting forces will be equal to the resolved part of their resultant. Okay, so C cos theta is equal to A cos 0 plus B cos alpha. Why this is 0 degree? Because we take the resolved part along the line of action of A. So the angle between this line and with this line is 0. Okay, so that's why this is 0 degree. So A plus B cos alpha is equal to B. How we substitute C cos theta by B? So cos alpha is equal to B minus A by B, and the resultant C is equal to root over A square plus B square to AB cos alpha. We substitute cos alpha by B minus A by B, and we get C is equal to B root over B square minus A square plus 2AB. This is the required statement we need to prove here. So I have to stop here. I have no more problems right now ready for you. I hope in my next video I will bring some more problems from the same topic and more theories. And please suggest me which problems you are facing, problems or facing you seem difficult for you, and I will make that easy for you. I'll try to make that easy for you. And please support my channel and subscribe my channel and motivate me. It will motivate me to work more for you. Okay, thank you everyone. Assalamu alaikum.